Howdy, howdy, this is Mr. Potter, and today we're going to be talking about Fibonacci numbers and Lucas numbers. So first I want to talk briefly about what they are. You've heard of Fibonacci numbers before. They start with 1, 1, and then each following number is the sum of the previous two. So 1 plus 1 will give me 2, 2 plus 1 gives me 3, 3 plus 2 will give me 5, 3 plus 5 would give me 8, and so forth. Lucas numbers operate the exact same way, except they start with a 2, 1 instead of a 1, 1. So 2 plus 1 gives me 3, 1 plus 3 gives me 4, 3 plus 4 is going to give me 7, 4 plus 7 is going to give me 11, and so forth. These numbers continue the same way as the Fibonacci sequence does. And what's really interesting is that there's a relationship between Fibonacci numbers and Lucas numbers. In other words, I can use Lucas numbers to find Fibonacci numbers. I can use Fibonacci numbers to find Lucas numbers. And the idea here is that if I want to find a particular Fibonacci number, all I need to look is at the next position Lucas number and the previous position Lucas number and divide that sum by 5. What that means is that if I wanted to find the sixth Fibonacci number, all I need to do is I need to take this previous number and the successive number, 29 and 11, add those together. So 29 plus 11, that's going to give me 40. And when I divide by 5, I get 8. Similarly, if I wanted to find this number in this position here, what I would do is I would take 47 plus 123. And that's going to give me 170. And 170 divided by 5 gives me 34. In that same vein, I can find Lucas numbers by taking the sum of the previous and next Fibonacci number. So if I'm looking for this particular Lucas number, well, the previous is 1, the successive is 3. 1 plus 3 gives me 4. If I'm looking at this Fibonacci number, or excuse me, this Lucas number, 13 plus 34 will give me 47. Finally, if I want to find a Fibonacci number in an even position, all I need to do is multiply the Fibonacci number in the halfway down position times that corresponding Lucas number. So if I wanted to find the 10th Fibonacci number, all I need to do is look at what's happening in the 5 position. 5 times 11 is 55. If I want to find the 8th number, all I need to do is look at what's happening in position 4. 3 times 7 is 21. So there are relationships between the Fibonacci numbers and the Lucas numbers. And there's one other place that we can find Fibonacci numbers in an unexpected place. Now you're familiar with Pascal's triangle, the idea that each number in the triangle is the sum of the two numbers above it. So 1 plus 1 gives me 2, 1 plus 3 is going to give me 4, 6 plus 4 gives me 10, 15 and 20 gives me 35. That's how the numbers are generated. And you may also be aware that if I take the numbers in a row and add them together, I'm going to get powers of 2. So 1 plus 3 plus 3 plus 1 gives me 8. 1 plus 5 plus 10, that's 16, plus 10 plus 5 plus 1, another 16 is going to give me 32. Each row will always add up to a power of 2. But what you may not be aware of is that I can add certain rows in certain ways and get those Fibonacci numbers. So I've got these slightly slanted rows, and if I add these together, well, that's 1, that's 1, that's 1 plus 1, that's 2. 1 plus 2 makes 3. 1 plus 3 and 1, well, that's 5. 1 and 4 and 3, that's 8. 1 and 5 is 6, and 6 more is 12, and 1 more is 13. And notice that I get these Fibonacci numbers, 7, 17, 21. And if I take the 1 that would be on this 8th row, plus 7, 8, plus 15 is 23, plus 10 is 33, plus 1, I get 34. And as long as I draw these diagonal lines that are basically offset by a little bit, I'm going to get the Fibonacci numbers. Can you find the Lucas numbers in Pascal's triangle? Have a great day.